All right, let's pull back the curtain on the incredible hardware that powers our digital lives. I mean, everything from gaming to streaming to creating content, it all runs on a really powerful team of components working together. So let's dive in and meet this high-performance team to see how they actually make all that magic happen.
Just look at this. It's intricate, it's beautiful, and it's rendered in an instant. Have you ever really stopped to think about what's going on inside your computer to make this possible? It feels like magic, right? Well, I promise you, what's actually happening is even more impressive. And that's really the key to understanding all of this. The best way to think about your computer isn't as a single object, but as a highly specialized team. Every single member has a critical job to do, and when they work together perfectly, well, that's when you get these amazing results. So let's meet the stars of the show, shall we? We're about to meet the key players on this hardware team, and we're going to break down exactly what each one brings to the table. First up is the one in charge of the whole operation. This is the CPU, the Central Processing Unit. If you think of this whole thing as a movie production, the CPU is the director. It is the brain of the operation, managing the entire show. It's constantly reading the script, which is just the software code, and telling everyone else on the team what to do and exactly when to do it.
And modern CPUs have gotten way more advanced. Instead of just having one director, now they have multiple cores. It's kind of like having a whole team of co-directors on set. This allows them to juggle multiple complex tasks at the exact same time without ever missing a beat.
Next up, meet the specialist, the GPU, or Graphics Processing Unit. Now, if the CPU is our director, the GPU is the Visual Effects Supervisor. Its job isn't to run the whole show. Nope. Its job is to do one thing and do it exceptionally well. Create visuals. And it does this with what you can only describe as an army of thousands of little assistants, which are also called cores. And this comparison right here shows you the fundamental difference. The CPU is a strategist. It has a few very powerful cores that are amazing at handling complex jobs, one after the other. The GPU, on the other hand, is an army. It has thousands of simpler cores that are designed to tackle one huge, repetitive job, like figuring out the color of every single pixel on your screen, all at the exact same time. Now, of course, this team needs a place to work, right? That's where RAM comes in, random access memory. It's like the on-set assistant, holding all the scripts, the props, the assets, all the stuff the director and the VFX supervisor need right now. So the more RAM you have, the bigger and more complex the project you can work on smoothly. Okay, but what about all the stuff you aren't working on at this very second? That's where storage comes in. It's the project library. On the left, you've got the old school mechanical hard drive, or HDD. It's great for archiving tons and tons of data. But on the right, you have the modern solid-state drive, or SSD. This thing is like a lightning-fast digital catalog that lets you find and load your project files almost instantly. Okay, so we've met the team. Now let's see them in action. We're going to put them through their most demanding mission possible, running a modern video game. This is really where their coordination is put to the ultimate test. So to create just one single frame of a game, and this happens 60, maybe 120 times a second. Here's the dance. First, the CPU, our director, figures out all the game logic and physics and tells the GPU what it needs to draw. Then RAM, our assistant, instantly hands over all the needed textures and models. Right after that, the GPU, our VFX supervisor, works its magic, rendering that beautiful 3D scene. And all the while, the SSD, our librarian, is getting the data for the next level ready to load in a flash. And this is exactly why a powerful GPU is so critical for gaming. I mean, trying to create those fluid, lifelike visuals with real-time lighting and shadows 60 times every single second, that's a job that would completely overwhelm a CPU by itself. It absolutely requires a dedicated visual powerhouse. But hey, not every computer is built for gaming. Just like in the real world, you assemble a different kind of team for a different kind of job. The hardware you'd want for, say, professional video editing is actually pretty different from what you'd want for the ultimate gaming rig. You can think of it like this. A gaming PC is a sprinter. It is built for pure, raw speed and responsiveness. So it prioritizes a CPU with the fastest possible clock speed and a GPU that's optimized for pumping out the maximum number of frames per second. A professional workstation, though, that's a marathon runner. It needs a CPU with tons of cores for heavy-duty parallel processing, a GPU built for precision and stability, and even special error-correcting RAM to make sure everything is reliable over those long, intense rendering jobs. So what about that super powerful computer you carry around in your pocket? Well, your smartphone uses the exact same kind of expert team. But here they've been miniaturized and integrated onto a single incredibly power-efficient chip. It's called a system on a chip, or SoC. It's just an amazing piece of engineering that has to balance performance with battery life. But what happens when one member of the team just can't keep up? Well, that's what we call a bottleneck. If your RAM can't pass data fast enough, or your storage is too slow finding files, the whole production just grinds to a halt. Even something as simple as the team getting too hot can cause everything to slow down. So remember, a balanced team is a fast team. So this brings us to a final, really important idea. All of this incredible hardware, this amazing team we've been talking about, it's only half the story. To create the magic we see on our screens, it needs a conductor. It needs the software. At the end of the day, it's this perfect symphony between the hardware team and the software conducting them that makes everything possible. The immersive virtual reality and seamless streaming experiences of tomorrow, they're going to depend entirely on how well these two halves work together in perfect concert. And that kind of leaves us with a fascinating question to think about. As our games, our movies, and our virtual worlds get even more complex, even more demanding, what will the multimedia team of the future even look like? What new specialists are going to join the team? It's something to think about.